Welcome you all. I am Nuan Jaligoda and today I am going to introduce you the tool named PlatformIO that can be used for your cyber physical systems engineering project. I think all of you know about microcontrollers and development boards like this. And for your knowledge, there are a lot of different microcontrollers and different development boards available in the world now. So what is the difference of microcontrollers from other electronics? Yes, you already know that. The microcontrollers we can program. That means we can write a program to behave based on some inputs from outside environment and take some decisions and give some output to the world. So that is the why we are using microcontrollers in embedded devices to obtain some input, process and give some output. For that purpose, we need to write a program and somehow we need to write that program into those devices. For that process, we are using IDEs. IDE means Integrated Development Environment. So I think you all know this IDE. This is Arduino IDE, which came for basically program Atmel family Arduino development boards and microcontrollers. This is not the only IDE available. Almost all the microcontroller manufacturers, vendors are providing their own integrated development environments to program their microcontrollers. These, these two are another well-known IDEs. As an example, MPLAB X is the IDE we can use to program PIC family microcontrollers. And you can see there is another IDE available in here known as ESP-IDF. It is the IDE provided by Expressive to program ESP family microcontrollers and system on chips. But when we are using these kind of IDEs and when we are working on different kind of development boards, we need to download and set up all these IDEs separately. And there is another point, not all these IDEs are freely available. So sometimes we need to pay for those IDEs, just like we are purchasing some software license. So let's move into the today's topic, PlatformIO. I think now you know that we need IDE to program microcontrollers, and there are a lot of different frameworks, different development boards and microcontrollers available. So PlatformIO came as a solution to the embedded system development with a large number of different microcontrollers. That means the PlatformIO known as a professional collaborative platform for embedded development. That means you don't need to stick into one single vendor or manufacturer. With the PlatformIO, you can program with 48 different platforms under 26 frameworks, and it supports more than 1,000 development boards. And in the PlatformIO, you can find 200 plus different examples. You can easily start from some example. And the most important thing is it supports 11,000 plus different software libraries designed for embedded devices to interact with various sensors, modules and actuators. And you can see there are a lot of microcontroller manufacturers, vendors, and their platforms are supported by our tool, the PlatformIO. Now I know that your next question is how we can use this PlatformIO. It is a platform but it is not actually an IDE. However, we can use the PlatformIO as an extension on almost every available popular IDEs. I think you all are familiar with Visual Studio Code and Atom IDE. Apart from those two well-known open source free IDEs, the PlatformIO came as an extension for other IDEs too, like Sublime Text, Eclipse, NetBeans, Code Anywhere, and there are a lot of different IDEs support PlatformIO. Yes, there are a lot of facts we can discuss about the PlatformIO, but however, I thought to introduce you all those features as a demonstration. So there is 5 main steps I identified and decided to demonstrate you. So first part, it is configuring and set up a PlatformIO project. So I decided to use this very simple example with one sensor and one development board. This is DHT11 sensor. It is a temperature and humidity sensor. You can measure the temperature and humidity of atmosphere using this sensor. And we only need to power up this sensor, and only one signal wire we need to connect into the development board. And we can get the measurements using DHT11 library. So the second and third parts of this demonstration is introducing you how to install and set up platforms, frameworks, and boards, and as well as library management, how you can add the device specific library into your project. So let's move into the demonstration part. First, I visit our GitHub organization and start a project. Let's name this as PlatformIO demo, and we can use the template, the same template we are using for your project, and let's give some description. And let's make it public. Yes. As the next step, we need to download or clone this repository into our local machine. So in this time, I am using an IDE for that purpose. I think you all are familiar with this Visual Studio Code IDE. I will clone the repository into my computer. Using git clone command. And I can open that folder like this way. Now you can see there are 2 folders already available under this repository, and I need to initiate the PlatformIO project in here. Before that, I need to install the PlatformIO IDE extension into Visual Studio Code. You can find this extensions button, and in this search box you can type PlatformIO. Since I already installed it, I can see it is already available. Otherwise, you need to click on the download button in here and install it. So after you installed the PlatformIO IDE, you can see there is an icon like this in your toolbar. You can click it and open the PlatformIO home. Next, you need to create a PlatformIO project. So you can use new project button and need to provide the names. For that, this time I will provide the name as firmware, and I select Arduino Uno board as the development board, and as the framework I am selecting Arduino, and I need to specify the location where I need to create this project. So I select the repository I cloned recently and finish. It will take some time to initiate the project. Yes, now you can see the project is initiated. So you can see there are few folders available in here. These different folders have different purposes. So you can see, read the instruction available in this folder for get some more information. As a standard, industry standard and best practice, we are doing implementations on the folder named SRC. SRC is a shortened form for source. You can see there is a CPP file available as named main.cpp. There we are implementing our code. So this is the basic code structure, and I need to introduce something new. In here you can see there is a file named platformio.ini. This is the configuration file automatically created by the PlatformIO in this project. The main reason of this is that the PlatformIO supports large number of different platforms, boards, frameworks, and when we are compiling the source code, PlatformIO need to know what is the platform that code should be compiled and what is the target development board. That is why we are having this platformio.ini file in the top of our project folder, and there are a lot of other configuration options available. So you can visit this link and learn about these things. Okay, let's move back into the demonstration, and let's have very small program. Let's remove these comments, and this is very simple program. Now let's start to compile this program. For that, that you need to visit PlatformIO tab again. If you correctly configured your project, it will automatically identify your build environment and show you available commands in here. You can also find some of these commands in this toolbar also. First thing you need to do is build in the project. Let's click on this build button and see what is happening. So since we configured the project with platformio.ini, it will look for the Atmel AVR platform and Arduino framework, and the Uno board. So if we previously not installed necessary compilers and tool chains required to build this program, the PlatformIO will automatically download those and compile. So now you can see the program is correctly and successfully compiled. The next thing you need to do is upload this program into your development board. I already connected an Arduino Uno board into my computer. So I will click on this upload button. Usually PlatformIO automatically identify what is the COM port we need to upload the firmware. Now you can see the firmware was completely and correctly uploaded into Arduino Uno board. So I will share the video feed. Now you can see the pin 13 inbuilt LED will blink according to our program. Yes, now you saw that we have completely done a small project. So let's move into next demonstration. Now I'm going to show you how we can add a third-party library into our project and how we can use that library. So let's move back into our PlatformIO home page. And you can see there are a lot of icons available in this toolbar. Let's first try with platforms. Here you can see there are a lot of platforms available in PlatformIO, and if you need to use one of those platforms, you need to select it from some of tab in here and click the install button. I will show it here. You can see if you need to install this platform, you need to select the version. In most cases, you are using latest version and click on install. Then it will automatically download necessary compilers, tool chains and configuration details for development boards for you. And after that you can see all the boards are available in here with some details. And you can see there is another tab called libraries. From there you can easily search libraries under by just typing the name of sensor or module you need to find. For this demonstration, I previously mentioned that I am going to use DHT11 sensor. So I will type DHT11 in here and search. Now you can see there are a lot of libraries already available for DHT sensors, and some of them are generic libraries and some of them are specially targeting some development boards. As an example, you can see this sensor library is specially written for ESP family microcontrollers. So in this demonstration, I am using most popular and most used library, DHT library implemented by Adafruit Industries. So first you need to download this library and add to your project. So I selected the library and then I need to select the project and click on this add button. So then the PlatformIO IDE will update your project configuration file with this library detail. Now if you revisit the PlatformIO.ini file, you can see there is a new line added into the configuration file with the details of this library. So let's try to write some program using this library. So in most cases, libraries are coming with some examples. So you can easily start with this example by copying this and paste, and I will make some cleaning task. I think you all are familiar with this kind of programming, so let's make it little simple. We will remove these parts and delay it 1 second and read the measurements. I am using DHT11 sensor. I change this, and I need to connect DHT sensor into the pin number 2. Now I will connect this DHT11 sensor into the development board. And let's try to compile the program. I can click upload button, then it will build the program and upload it into the development board. So if the library is not previously installed or downloaded into your computer, it will automatically download it, compile the program and upload. So now it is completely uploaded into the development board. So next we need to check whether it is working. So in this example, we are using the serial monitor. So you can access the serial monitor interface of this development board from here. You can use this monitor option to access the serial monitor. Yeah, you can see that temperature and humidity readings are coming through this serial monitor. Yes, this is the basic example we can try with DHT11 sensor. Now let's move back into our presentation. When we are writing a program for large software, we have different small units, and we need to make sure all these small units are working fine when we are trying to release the software or complete the project. So there is a industry practice in software industry on system testing. There are a lot of different system testings, software testings available, and the small scale testing we can known as unit testing. So we are writing some testing situations for small components, and when we can run those testings at some time and check whether our program give correct output as we are expecting. So this is the basic idea of unit testing. And like the software based unit testings, we can also write hardware related unit testings, but they are little different from the standard software unit testing. Let's assume you are writing a program for an embedded system. This is your target device. Let's say it is Arduino Uno board. But we are not writing the program on Arduino Uno board. Before that, we need to install the Arduino IDE or Platform IDE and write the program in the host machine. We are writing the program in host machine, and we are compiling the program into binary files, and then we are uploading the program into target device. This is known as cross compilation. We are writing program in one platform but compile it for different platform. So let's move into embedded unit testing. There are three types of possible unit testings available. I will describe one by one. The first one is testing on host machine or cloud. Here host machine is this one. You are writing the program targeting this device, but you can run some testings on host machine also. As an example, in your hardware program, or we are usually call this as firmware, in your firmware there can be data structures and algorithms which are not directly connected with hardware resources. So those things you can try on the host machine. You can test the functionality of these things in your host machine. It is the first type of embedded unit testing. The second type, embedded device testing. That means you need to make sure some hardware functionalities are working correctly. So you can write test targeting hardware components like sensors, actuators and modules. So then you need to make some change on the hardware unit and check whether the response received from that hardware unit is same as what you expected. So this is the second type of embedded unit testing. And this is the third type, remote testing. That is very similar to this one, but now you are running or controlling the test cases on your host machine, while the target device, let's say remote target device, is connected into remote machine. That means you can write some test on your computer and you can run those tests on your friend's computer, the device that connected into your friend's computer using remote testing. All three of this type of embedded unit testings are available with PlatformIO. However, due to limitation of time, I am only describing and demonstrating the second option, second type of unit testing, embedded device testing. Let's move back into our project. In our hardware project structure, you can see there is a folder named test. Inside that we can declare what are the unit testings to be executed when we are running testing cycle. So first we need to create new file. Let's name it as test.cpp, and we need to implement the testings in here. So I will start these testings with some example. Let's visit PlatformIO website. And go into documentation. There we can see the unit testings under professional tools. So let's start this with Blink project. That is very simple project that we are testing the LED blinking option of our Arduino board. So let's remove this part for now. So it will use Arduino header, and the testing is performed using the unit testing library known as Unity. So there, first you need to set up the development board with some conditions. This is same as what we did previously for our main.cpp. But in here, first we need to start the testing framework using this function, and we can include testings by calling this function, and we need to pass the function name into this method or function. So in this test, first it will check the LED built-in pin is same as the pin number 13, and then it will try these two testing functions for 5 times. Let's say check whether what are the testings. Yeah, this is the first test, and it will check whether this LED built-in is the number 13. If this one is equal to 13, the test is passed. Otherwise, test will be considered as failed. And this is the next test run in the loop to check LED is high. First, we are writing digital write into this pin. Digital write the pin as high, and if we are checking whether digital reading of this pin is equal to high, same way we are using state low function. This will change the digital output of pin number 13 into low and read it back and check whether it is low or not. You can click on this test button, then it will compile the program, testing program, build it and upload it into the run, and then we can see the result of this test command line tool through the serial monitor of the device. Now you can see it is compiled and uploaded, and then each test will be executed. You can see we run this test once and this other two tests 5 times. So you can see 10 lines and all the test cases are passed. So let's make small change in here and check what will happen. So instead of making digital write this pin number into high, I change it low. Now when the program will be executed, this will stay at low, but this trying to check whether it is high. So I will run the test again and see what will results. Now you can see the expected value of this pin is high. Somehow it is not correctly worked because I changed the logic to fail this test. So you can see this test is failed. So likewise we can write our own tests. So this is the basic blink test. So I will add another new test to test the DHT11 sensor. So let's make this test as test DHT11, and we are trying to test whether this sensor works correctly or not. So that one we need to add some libraries required to run the program, set up DHT11. So I copy necessary files from here into my test file, test code. And before testing the sensor, I need to set up this sensor in here. So yeah. Then I need to check whether temperature and humidity can be read. So here you can see we can get the temperature reading from device, and if it is not a number, we can identify it is as an error situation. So we can use this logic to test the functionality of the sensor. So in this test case, I am writing test assert equal and we are expecting this situation to be false. So yes, but before we need to read the value from sensor, so I need to add these two lines also. Now we are observing the temperature reading from the sensor, and it is not a number, the test should be failed. So let's make it more clear. Yeah, I am using not equal as the test. So this is not a number function is true, the test should be failed, otherwise it should be passed. So you may think about where this come. So if you visit this unit testing documentation file in the PlatformIO, you can see there are a lot of different commands available in here. You can use this kind of things to test the functionalities. So I implemented this, and I need to, let's run it 5 times. I will run test and give this test in here. And now you know that I already connected my DHT11 sensor into the development board. So I can directly upload the program, this test program, and check whether it gives correct readings, that test can be fast or not. Yeah, I think I did some mistake in here to check the functionalities of failure conditions. But however, you can see the DHT11 test is passed because the test reading, temperature reading of the sensor is not actually null. It is some numeric value. But let's disconnect the sensor from the board. Here I disconnect the sensor from the development board, and let's try this test again. Now the temperature reading, the development board can't identify a sensor reading because it is already disconnected. Let's check whether the program can identify the sensor is not connected or not. Yeah. Yes, now you can see the DHT11 test is failed because the sensor is not connected. Yeah. Likewise, you can write this kind of testings for any sensor you are using with some testing operations. So this can be very useful when you are preparing your project for the final presentation or demonstration, live demonstration, and you need to test all the functionalities of your components within a small amount of time. So that in that kind of situations, you can implement some unit testings sometime before the demonstration or presentation and run it at any time you need to test the functionality of your embedded device. So this will save your time as well as you can make sure your everything is connected and behave well before using the device. Yeah, this is the end of the unit testing demonstration. Let's move back into our presentation. The next part I decided to demonstrate to you is known as static code analysis. Let's consider again embedded system development. You are writing your program in a computer, but somehow your program will be run on an embedded device and there is no any display. In most cases there are no any display available. There is no, if a bug or malfunction happen, in most cases we can't easily identify those. And actually these embedded devices have very small amount of memory. So small memory and easily can be overflow this memory. Actually there are a lot of possible errors can be happen in your C or C++ program. Some of them are listed in here. Null point dereference, indexing beyond array bounds. This is very common one. If you have array of 10 indexes and you are trying to access the index number 11, actually it will give some garbage value or error. So, and yeah, like you write trying to get some reading from uninitialized object, these are possible errors in your code. And you can easily identify this kind of situations using some advanced algorithm analyze your program. So it is the thing we called static code analysis. This is advanced algorithm. It will check your program and try to identify these kind of situations, possible situations. So you can write your program and run this static code analysis tool and it will identify these kind of possible issues in your code. Then you can easily fix those things. And yeah, there's another one in here. So this is not actually an issue or defect, but let's say you are writing lot of functions, but actually you only need one or two of them. All other functions are available in code, but actually the memory of an embedded system is very low compared to computers. So this kind of unused variables and functions are overhead. So this static code analysis tool also can identify those of kind of things and warn you before uploading your program. So let's move into the demonstration again. Now you need to visit the PlatformIO homepage again, and there is a tab called Inspect. From here you can select your project. This is your project and you need to select the environment. So you can check this test, inspect memory test. It will only check the issues or defects related to memory, and you can enable this option to check your codes also. First I will show you what will result when you run inspect memory program. Usually it will take significant amount of time, so let's wait until the result is given. Hope you all can see this result. So it will show some statistical properties, how much amount of RAM and flash memory used by your program, and what are the top files, top symbols used by your program. You can see what the symbols, files, some sections, and what are the usage of these sections in your memory using this inspect tool. Yeah, you can see these register details and all, everything using these tabs. Okay, and we will try to run the check code experiment also. The defect is suggest defect level medium, high or low, suggest defects. Since our program is very small one and we follow standard methods, there are no much defects available. So in here you can see every detail related to each and every defect. Yeah, this is the end of the static code analysis demonstration. You can also use this tool to improve your code quality of your project. PlatformIO isn't limited to these functionalities. There are a lot of some advanced tools available in PlatformIO. So I will describe some of them and give you the links and to the resources. You can try these features by yourself. The first one is remote development. This can be very useful for nowadays, since you are now working and studying from home, and only one of you have access to the hardware components. But if you can use the remote development tool provided by the PlatformIO, you can ask the friend who have access to the hardware component. He can run this remote development mode on his computer and connect the device. Then you can remotely connect into that device and write some programs, try to upload it and see the output of the device. So this can be very useful tool for you. And this is the second one, OTA, over the air firmware uploading, is another useful tool or functionality. Let's say, I assume most of you are working with IoT related projects. So your devices are connected to internet. So in this case, you can upload or update the device firmware without connecting a cable into the device. You can try update and upload the program into devices via internet. So it is known as OTA, over the air upload. It is also useful when you are working with IoT related projects. And third one is continuous integration. It means, let's say you did wrote some unit testings in these steps. So you can test those unit testings and some checks on whether you can build the project automatically using continuous integration tool. So I will show it with here, this one. So in our previous workshop, we introduced you the GitHub actions. So you can use the GitHub action workflow file provided by PlatformIO to test the functionality of your PlatformIO project. You just only need to copy this file text and create a file, GitHub actions file. And when you commit your code into the GitHub repository, it will automatically run this and test your program. So this also a very useful tool when you are working in a group project. And the last one is actually not a tool provided by PlatformIO, the feature available in C and C++ based language about preprocessors. With preprocessors, you can easily control your program. Just say you can write a program into generally targeting both Arduino and ESP family microcontrollers, and let's say their pin arrangements are different, then we can write C preprocessor statements to decide at the compile stage what pin arrangement should be used for the firmware. So details about these techniques are available in these links, and I will share this presentation with you so you can visit those links and try on these things. If you have any question related to this demonstration or presentation or anything related to Platform IO, please feel to contact me. So thank you all of you.